So today we are going to first talk about factors, multiples, prime numbers, and then we will do HCF and LCM. Okay. So
Okay.
factor is a number which divides into another number exactly with no remainder, like the factors of 12. So we think of numbers that uh, when we divide it, uh, when we divide with that number 12, we get no remainder. Like 12 times 1 is 12, right? And 2 times 6 is 12. 3 times 4 is 12. So all these numbers are factors of 12. Okay. So the
Okay.
factors of 12 are 1, 2, 3, 4, 6, and 12. You can see here 1, 2, 3, 4, 6, and 12, right? Hmm. So these are the factors.
Yeah.
And then multiple of a number is a number in its times table. Like mu- um, let's say we want to find multiples of 4. So multiple of 4 is like 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. So these are the first 5 multiples of 4. Okay. So now next is prime numbers. So prime numbers, a prime number is a number that has only two factors. It has only two factors, one and the number itself. Okay. For example, 2. It has only two factor. It is only divisible by 1 and by itself, which is 2. For example, 3. It is only divisible by 1 and the number itself, 3, right? Similarly, 7, 5.
Yeah.
7 is a prime number because it is only divisible by 1 and number itself, which is 7. Is 9 a prime number? Is 9 a
9?
prime? Yeah.
Yeah.
No, it is not because it is divisible by 1, it is divisible by 3, and then it is divisible by 9. So it has more than two factor, right? So that's why it is not a prime number. Okay, clear?
Clear.
Yeah. So let's go deep into factors. So like I told you, the factors of 12 are 1, 2, 3, 4, 6, and 12, right? Can you tell me
Mm-hmm.
the factors of 30? What are the factors of 30?
15.
Yes, 15 is a factor of 30. Tell me some more.
1,
Yes, 1.
2,
Yes,
3, 10.
yes,
Um, 30.
yes. 5, right? So,
Yeah.
but if you see out of these,
7. 6.
yes, 6.
6.
Very good. 6 is also prime. I mean, factor of 30. So, if you see out of these, only out of these, can you tell me which one are prime numbers or prime factors from this list of numbers?
5.
Okay, 5 is a prime number. What else? 5,
Um, 3.
3, good. And
And 1.
no, 1 is not a prime number because it has only
15.
one factor itself. 15 is not a prime number. It has um,
Uh,
3, 5. These factors are also there for 15, right? Prime number has only two
yeah.
factor, 1 and number itself. 2. 2 is a prime number, right? So
Yeah.
prime factors are only 3, 2, 3, and 5 here, right? Other numbers are not prime number, they are composite. Numbers which have more than two factors are called composite. Okay. 1 is neither prime nor composite because it has
Okay.
only one factor, which is 1, right? Now,
Yeah.
yeah, so basically we are talking about prime factors only. So prime factors of 30 is only 2, 3 and 5, right? Hmm.
Yeah.
So yeah, for example, if I talk about 6, 6 is a composite number. Uh, Composite number means it has two or more factors. But if you see, the factors are 2 and 3. 2 and 3. So we can factor it into prime numbers, right? 2 times 3.
Mm-hmm.
2 and 3, these are prime numbers. Okay. So basically, we can factor a number into its prime factors. Let's take 36. If I have 36, I can use a tree method. For example, 36, because if you see the last digit is even, right?
Yeah.
Even number. If my last digit of my number last digit is even, then it is divisible by 2. Even means if last digit is 0, 2, 4, 6, 8. Okay, like here we have 6, so that means it is divisible by 2. So I can divide it with 2. If I divide it with 2, what would I get? Yeah, 36 divided by 2.
Um,
Quickly, be quick. Yes, yes. So
18.
exactly, 18. Again, 18 is a even number, right? Because last digit is 8 is even.
Mm-hmm.
So again, we can divide it with 2. What would you get if you divide it with 2? 18 divided by 2 is
9.
9. Good. 9 is odd number. This we can divide it with 3, right? So 9 divided by 3 is
Mm-hmm. 3.
3. Very good. So if you see all these factor 2, 2, 3, 3, these end factors are prime numbers. All of them are prime numbers, right?
Mm-hmm.
So this is how we factor a number it into its prime factors, right? So we can write
Yeah.
36 as how into its end factors, which is 2 times 2 times 3 times 3, right? You can see,
Yeah.
because these are the end numbers that we got at, we can't factorize it further, right? Because they are prime
Yeah.
numbers. So this is what we got, and that's how we do prime factorization. Let's try with 54. Again, this is an even number because last digit is even. 4 is even, so 54 is even. We divide it with 2. What would you get if you divide it with 2?
Um, 27.
20 what? 20. Yes, 27. This is odd number, but we can divide it with, does it comes in 2 times table? No, it appears in 3 times, so we can divide it with 3. What would you get if you divide it with 3?
7.
3 times 7 is 21, not 27.
I said 7.
Yeah, but 3 times 7 is 21.
8.
No, that's 27. 3 times what is 27?
8.
No, 3 times 8 is not 27. Yeah, it's 9, right? 3 times 9 is 27, isn't it?
Mm-hmm. Mm-hmm.
Now, what should I divide 9 with? What should I write here?
3.
3. And here? 3, right? Because
3.
9 divided by 3
Mhm.
is 3. Okay, so if you see the end products, or this 2, 3, 3, 3, this is what we got, right? So we can write 54 as 2
Mhm.
times 3 times 3 times 3, right? We have 1, 2, and 3 times we have 3, right? Clear?
Mhm.
Okay. We need to learn
Clear.
divisibility rules also, um, to be clear with this. Like if we can divide this. So divisibility rules, for 2, you need to check the last digit, right? If
Yeah.
last digit is even or 0, then it is divisible by 2. For example, 942. Last digit is even, so this whole number 942 is is divisible by 2. Next is 3. To check if a number is divisible by 3, if the sum of the digit uh, is divisible by 3, then we can divide that number by 3, okay? So suppose we have 1 and 9 and 2, okay? So if I add them, 1 plus 9 plus 2, how much is that? 10 plus 2, 12, right? With 12 is
Yeah.
divisible by 3, we know 12 is divisible by 3, right? That means this number is divisible by 3, okay? For
Okay.
4, we need to check the last two digit. If they are divisible by 4, the whole number is divisible by 4, okay? Suppose we have
Okay.
this. So last two digit 48 is divisible by 4. That means this whole whole number is divisible by 4. For 5, we check last digit again. If last digit is 0 or 5, then the number is divisible by 5, right? Like 50. Last digit is 5. For example, 255, right? Next
Yeah.
for 6. If a number is divisible by both 2 and 3, then the number is divisible by 6. Okay. For example, 12. 12 is divisible by 2. 12 is divisible by 3 also. It is divisible by 2 and 3. So that's why it is divisible by 6. Okay. For 8.
Yeah.
If the last three digits are divisible by 8, that number is divisible by 8. Okay. Like if we have, suppose, if last three digit, like in this case, last three digit, they are divisible by 8, right? So this whole number is divisible by 8.
Yeah.
For 9, if the sum of the digit is divisible by 9, that number is divisible by 9. For example, um, if we have, suppose, 9 1 and 1 9. So if I add them, 9 plus 1 is 10, and this is 20 actually, or let me just change it. This is 10 and this is 8, okay? So if I add them, I get 18, right? Which is divisible by 9. So that
Mhm.
means this whole number 918 is divisible by 9 also. For 10, we just check the last digit. If last digit is 0, then the number is divisible by 10. Okay. For example, 3000. The last digit is 0. So this is divisible by 10. For example, 280. Last digit is 0. So it is divisible by 10, right? Clear?
Yeah.
Yeah, so these are some divisibility rules that you should know. Um, so we have learned about prime factors, right? Is that clear? Hmm.
Yes.
Okay. Can you tell me the prime factors of 18? Divide it. You start with 2. What would you get here?
9.
Yes, and again, if you divide it with 3, you will get,
3,
yeah, so the prime
3,
factors are, hmm, yeah, 2 and
2
3.
and 3.
Okay, so you can write 18 is equals to 2 times 3 times 3, because this, and this, right? Hmm.
Yes.
Okay. Um, is that clear? Yeah?
Yes.
Okay, that's great. Now, um, because we will be using this prime factors and all in HCF and LCM. Okay. First, we should know how to find common factors and all. Let me just do. Yeah. Hmm. So suppose, uh, let's say the question is asking you to find common factors of 8 and 12. Okay. So what are the factors of 8? Can you tell me the factors of 8?
Mm,
We always start
2,
with 1.
4, 8,
Always
1.
start with 1. 1, okay. 1, 2, 4, you already said, and 8, right?
Mm-hmm.
Okay, then tell me factors of 12.
1, 2, 6, 4, 3.
3, 4, and 6. And then
12.
12. So there are some numbers that you see in both, like 1, 2, then you see 4. So these are called common factors. Okay, so 1, 2, and 4, they are common factors of 8 and 12, right?
Yeah.
1, 2, and 4. Hmm. So now then there is LCM. LCM is actually common factor. You will you must have heard HCF. HCF is highest common factor. So if you see in these two factors, which one is highest out of these are the three common factors. So what is highest here? 1, 2, 3. What is the largest one?
4.
4. So HCF of 8 and 12 is 4. Okay, we just find the common factors, and the highest one is the HCF. Okay, clear? We
Yeah.
learned about multiples. Let's say we have to find multiples. Let's say we have to find common multiples of 8 and 12. So first we write multiples of 8. Can you tell me multiples of 8?
Um, multiples of 8.
Yes, we start with 8. Yeah, what
Um,
multiples of 8 is 8. Then just tell me 8.
um,
Hmm? Yeah, what are multiples?
16.
Yes, after,
16.
yes, 16. Then
24.
yes, then 32, then 40, 48, right?
32. Yeah.
56, and then 64, and then 72, and then
72.
yeah, 80, right?
80.
Yes.
Yeah.
Then we write multiples of 12. So multiple of 12, again we start with 12, and then we have 24.
24. 36.
Yes. 48,
48.
60, 72, right? 84,
Mm-hmm.
96, 108, 120, like that. If you see the common multiple, first what number you see in both of them, that is common multiple. First is 24, then you can see 48, right?
Yeah.
And after that you see 72, right? So these are the common multiples. So we can say common multiples are 24 and then 48 and 78, 72, right? So these are the common multiples of
Yeah.
8 and 12. Now the LCM full form is least common multiple. Out of these common multiple, which one is least? Which one is the smallest? Yeah,
Um,
out of the
24.
24. So that's why LCM of 8 and 12 is 24. Clear? Is that clear?
Yeah.
Very
Yes.
good. Now there is a easy way to find LCM and HCF, okay? Because doing this
Okay.
method is like can be complicated, so we should use easy way. Let's say we have to find LCM of 24 and 36. So we can just do, we can write 24 and 36 together, and because they both are even number, if you see the last digit is even, so they both numbers are even. We can divide it with 2, right? So 24 divided by 2 is,
12.
yes, 12. And 36 divided by 2 is,
18.
yes, again we can divide it by 2, right? Because they both are even. Yes, divide 12 divided,
6.
yes, 6, and here,
9.
very good. Now we can divide both of them with 3, right?
Mm-hmm.
What would you get? 6 divided by 3 is,
2.
and here we get 3, right? So these two numbers, this list of number and this, here we got prime numbers. Now these are prime numbers, right? That means we can't factorize it further, right? Because prime numbers has only two factor, one and the number itself, right? Are you getting my
Yeah.
point? Okay, good. Now when you get prime numbers here, you can stop. You don't need to do anything now. LCM of these number, these two number 24 and 36 is, you need to multiply. Let me just write it here. LCM would be, just multiply these two, 2 times 2 times 3 times 2 times 3. Okay, so we multiply this and this. Okay, this is what I did here, right?
Okay.
This times this gives me LCM. If you multiply this, 2 times 2 4, 4 times 3 12, and 3 times 2 6. So 12 times 6 is 72. So the LCM of 24 and 36 is 72. Clear?
Clear.
Very good. Now let's find the HCF of same number. So HCF of 24 and 36. For HCF we do the same thing, 24 and 36. We divide them, both of them are even, so we can divide it with 2. Here we get 12, here we get 18. as we did in LCM, right? Again we divide by 2,
Yeah.
we get 6 and 9. And then we do it with 3, we get 2 and 3 here. Now else to find HCF, because this is highest common factor, so we need to just take this. Okay, when we get prime number here we stop, we don't do it further. HCF is just we multiply these things, 2 times 2 times 3. So 2 times 2 is 4, 4 times 3 is 12. So the answer is 12. If you notice the difference in LCM, we multiplied all of them, this and this, right? And that's how we got LCM. But in case of HCF, we just times these numbers, right? And that's how we find HCF, right? Clear?
Okay. Clear.
Very good. That's great. Um, let's try some more questions. So, yeah, can you find LCM of 12 and 18? Okay, I'm going
Okay.
to do it. I will make it here. You have to just answer. Yeah. With which number should I start?
Um, 2,
2. Yes. What should I write here?
6 and 9.
6 and 8.
Uh, what do you mean 8?
Oh, sorry. Yeah, actually 9. Okay. Then,
2 and 3.
okay, do it with 3 and 2 and 3. Now, should we do further?
No.
No, because we got here prime numbers. Now, what is
Uh-huh.
the LCM? We need to multiply this and this. Yeah.
Mm-hmm.
So we do 2 times 3 times 2 times 3, right?
Uh-huh.
How
So
much?
36.
Very good, 36. Now let's find the HCF of same numbers. Can you tell me from this what is the HCF? Yeah,
Um,
HCF of 12 and 18 is
huh?
what is the HCF of 12 and 18? For
Um,
for HCF we just multiply these two. 2 times 3 which is 6. Clear?
mm-hmm.
Yeah. So that's how we do. Clear?
Mm-hmm.